Hey, let's look at another piecewise function and see how we can graph it. So in this one, we have f of x equals 3x minus 4 when x is less than -1, and x squared plus 2 when x is greater than or equal to -1. So again, I'm going to go ahead and put these down as two different tables. And I'm going to have my x's, and I'm going to do my first one be my top function, 3x minus 4. And I'm going to plug in a few points so I can graph it. I want to make sure I plug in points less than -1, and to figure out where it ends, I also do want to plug in -1, but I'm going to star that -1 because I know it can't actually equal that. So things less than -1, let's do -2, -5, sub them in. I would get 3 times -1 minus 4, should give me a -7, 3 times -2 minus 4, should give me -6 minus 4 is -10. 3 times -5 minus 4. -15 minus 4 is -19. So I can go ahead and start graphing this. So I'll draw an axis. And I was doing things less than -1. So -1 is there, and -1 was actually all the way down at -7. And since these go, well, I'll just pull it up a little bit. -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll go down to 10. So -1, -7 should have been 10, 9, 8, 7 here. So I'm going to go ahead and draw an open circle because I know it can't equal that. Okay, -2 and -10 would have been down here, and I can do a dot there. And then -5, so -3, 4, 5, -19 would be off our page. I mean, it's all the way down. So I can say, okay, well, I know it's going to keep going down. So I'm just going to draw a graph where it's just going to continuously be a line going down. So that's one part of my graph. I want to look at my other part of the graph. So my other part of the graph, x again, subbing things in, f of x equals x squared plus 2. This time, again, I want to sub in, well, looking at my x's, what is it allowed to be? X in this case is greater than or equal to -1. Then definitely sub in -1 because I want to get what my endpoint is. Could sub in 0, 1, let's just see if we can get an idea from that. So -1, if I sub in -1, I'm going to get -1, well, let's write it out, -1 squared plus 2. So 1 plus 2 is 3. 0 squared plus 2, so 2. 1 squared plus 2, so 3. So at -1, I actually have a point. I'm going to draw it as a point this time, up at 3. At 0, I have a point at 2, and at 1, I'm going to again hit a point of 3. I'm going to check and make sure that the behavior of this graph is going to keep going in this way. So if I sub in 2, yeah, it would keep going up. It'd be 2 squared is 4, plus 2 is 6, so it'd keep going up. If I subbed in 3, it'd keep going up. So I think my graph is going to continue going up, like that. So this is what my piecewise graph would look like. And there's a few things I can tell from a graph. We did domain and range last time. We can also do domain and range from a graph. We can say what x's actually exist on this graph. So if I look at -5, yeah, -5 exists on this graph down here. If I look at -10, keep going out, would -10 exist on my graph? And it would. It would exist all the way off, but it would exist somewhere down here. I could draw that x down to my graph. -3 would. -3 would exist down here somewhere. -1 wouldn't here, but it would here. So it looks like going to the left, all my negatives are existing. I could draw them down to my graph. Going to my right, I could say, well, -1 does exist. It exists there. 0 exists. 1 exists. 2 would exist up here. 3 would exist even further up. 4 would exist even further up. I could keep going. All of these x's would exist on my graph. There's no breaks in this graph. There's nothing turning it around. So it's going to keep going all the way to the right. So -infinity to infinity. You can look at my range. My range is my y. So I'm saying, do all my y values exist on this graph? So again, going down, yeah, negative 10 exists there, negative 19 we know exists over here. Could keep going down to negative 50, that would exist if I drew it all the way down over here somewhere. Going down, all of these are existing on my graph. I could draw it over there. So, negative infinity. Going up, negative 10 exists, negative 9 exists there, negative 8 exists there, negative 7 doesn't exist. Negative 7 is this open circle. So it doesn't actually exist on my graph. So the highest it gets going up is negative 7. Then it starts again, but it doesn't start at negative 6 or negative 5. It starts all the way up 2. So it starts, so and 2, and it exists at 2. I have a point there. So 2, 2, and going up, yeah, I could draw each of these y's over to my graph. So each of these y's exist on my graph. So 2, 2, infinity. Okay, so we're going to do a few more of these.